Braided material straps with attachment lugs are used throughout aircraft for a variety of purposes. Braided material is preferred for its flexibility, conductivity, and resistance to vibration and movement. This presentation will give an overview of the essential roles these components play in protecting aircraft and passengers from lightning strike, ESD, and other forms of errant electromagnetic energy. The electrical structure network, current return path, or simply grounding system on an aircraft is a complex framework of electrical components and structural elements, all designed to capture and dissipate current surge events, such as may occur during a lightning strike. The grounding system protects aircraft passengers, as well as sensitive electronic systems, from errant electromagnetic energy by providing a low-resistance, unbroken path to ground. The grounding system is critical to safe aircraft operation and is capable of handling a number of signal types, ranging from surges in power generation equipment to pulses from a lightning event to slow discharge along a fuel line. The grounding system leverages discrete electrical components, such as flexible power equipment ground straps, as well as the structural framework and fuselage of the aircraft itself. System functionality is similar in both aluminum as well as composite aircraft. When metallic aircraft are flying, they are inherently protected from lightning strike and other electrical discharges through the network of conductive and dissipative materials that make up the aircraft's structure. Additional lightning strike protective devices, such as static wicks and lightning arresters, are integrated in the radome of the aircraft and at exit points on aircraft wings and tips. But the main conductive path is the aircraft's aluminum fuselage, which carries lightning strike current from its entry point to planned exit points on the aircraft's extremities. Flexible ground straps are essential elements in this grounding network and are used to connect motors, power equipment, and structural areas adjacent to engines and fuel tanks directly to the current return path. In composite aircraft, the same approach is followed, with the addition of expanded metal foils, interwoven wire mesh, and other materials integrated into the composite structure to provide the conductive ground path. Ground straps play the same functional role of connecting electrical power equipment and other equipment to the composite aircraft's ground system via exposed ground points, augmented with additional conductive and dissipative materials. Bonding refers to the practice of creating an electrically conductive structural bond between the metallic framework of an aircraft to minimize differences in electrical potential and prevent the buildup and discharge of static electricity. Safety is again the primary concern, as well as suppressing electromagnetic interference. Bonding in aircraft relies on braided straps with mounting lugs, often referred to as flexible joints, as a redundant connector to the structural level bonds. Note that these ESD strap connections are generally designed to handle currents in the milliamp range, as opposed to the higher grounding currents handled in lightning strike dissipation. There are a number of key regulatory documents and guidelines that are sourced as standards in the design and construction of both grounding and static dissipation systems. These include DO 160, the go-to Bible for the management of electromagnetic interference in mission-critical systems, SAE ARP 1870B, the standard published by the Society of Automotive Engineers, with its complete guidelines for the design, installation, and testing of electrical bonding and grounding systems in aircraft. MIL HDBK 274A, the military handbook, aptly titled Grounding, Bonding, and Shielding for Electronic Equipment and Facilities, and AC 43131B, a critical advisory circular published by the FAA, with guidance on the selection of materials for ground straps and other bonding technologies. A third aircraft system utilizing flexible ground strap-like devices is the flexible Busbar or shunt used in aircraft power distribution systems. The straps, or shunts, are large cross-sectional area copper-braided connectors designed to meet the current carrying requirements of main aircraft power distribution. The products are designed with multi-layers of flat braids to carry currents in excess of 400 amps. AA59569 soft-drawn braided material is preferred for conventional ground strap applications. The tin-plated copper material is commonly used in both marine and aerospace settings and combines the excellent conductivity of copper with the good corrosion resistance of tin plating. Silver-plated copper may be selected for applications where highest conductivity and excellent resistance to corrosion are required. Nickel plating over copper is selected for excellent conductivity and best corrosion protection of the copper-plated material types. Finally, stainless steel is the most durable and corrosion-resistant material and should be selected for applications where high strength and resistance to environmental factors such as high heat, moisture, and salt are required. Stainless steel, however, is not as conductive as any of the copper core material types. Ground lug styles and types include square and radius lugs with variable mounting hole sizes, as well as single or double right-angle lugs. All ground straps are supplied with and without insulation material. Armorlite is an innovative material ideally suited for use in ESD bonding. Armorlite is a nickel or silver-clad stainless steel microfilament material that saves significant weight compared to standard QQB 575 materials. A 100% Armorlite ground strap, for example, is more than 70% lighter than a conventional plated copper ground strap of the same length. Armorlite ESD bond straps are supplied in different material blends optimized for the lower current demands of electrical potential bonding in aerospace applications. Armorlite at 100% is the lightest weight of the 4 available blends. The 75-25 and 50-50 blends of Armorlite and nickel copper improve bond strap conductivity at the cost of some additional weight. Armorlite CF is a special construction of high conductivity copper microfilaments with stainless steel cladding, which offers optimal corrosion resistance and increased current capacity. As mentioned earlier, bonding current carrying requirements are significantly lower than return path grounding, making Armorlite an ideal solution for weight-conscious bonding applications such as spacecraft and satellites. Glenair supplies M24749C Type 4 ground straps for use in naval applications. These 50% stainless steel and 50% nickel 200 ground straps are built in exact accordance with the mill standard and are available at any length required by the customer. For custom ground strap applications, Glenair offers customers a range of design options and variables, including various form factor crimp copper or stainless steel lugs, single and double mounting holes in customer-specified diameters, a full range of both catalog braid materials and off-menu choices, dimensional variations, length and width, and optional second or third braid strap for high surge current applications. In-house manufacturing of ground, bond, and busbar straps is another total vertical integration manufacturing process at Glenair. For standard duty ground straps, the process begins with the manufacture of QQB 595 braided strap material and the preparation of conductive lug materials. A hydraulic press is used to terminate the flattened tubular lug material to the braid. Mounting holes are drilled and the lug is selectively plated. Glenair lightweight Armorlite ESD bond straps are built around a low-profile lug that is soldered to the ground strap in a controlled and repeatable process. For applications where solder may be used, a discrete solder strip and the application of heat ensures a low-resistance termination between strap and lug. Electrical engineers may begin the down-select process at any number of points, including electrical, mechanical, and environmental. Mechanical form factor decisions include configuration of lugs, straight or right angle, basic dimensional details, and attention to space constraints, particularly proximity to equipment and strap flexibility. As mentioned earlier, corrosion resistance is a critical concern in ground straps and may dictate compromises in braid and lug material selection as well as plating. ASTM and other standards will often dictate exact material selection for ground straps used in different aircraft zones. For example, stainless steel may be selected in a highly corrosive environment, sacrificing better conductivity and lower resistance. As is always the case in power and grounding systems, only the customer can determine current carrying requirements for each ground point. Ground straps connected to power generation equipment, for example, would typically be specified to handle larger surge load requirements than a ground point designed to dissipate electrostatic energy. These factors influence the selection of single versus multiple braid layers and lightweight versus heavy-duty braid material. Insulation jacketing is commonly specified on ground straps in corrosive zones where exposure to caustic chemicals such as jet fuel or de-icing liquids is anticipated. Viton is a common insulation choice. Glenair can supply Viton per mil DTL 23053 13B on both standard duty as well as lightweight low-profile ground straps. Durelectric, with its excellent UV resistance, is also available as an alternative jacketing material. Glenair mission-critical ground straps are highly engineered solutions designed to meet the exacting requirements of land, sea, air, and space applications. These solutions are designed and optimized for superior mechanical, environmental, and electrical performance. Like all Glenair product families, Series 107 ground straps are a high availability product line, meaning all popular part numbers in various lengths have been loaded into same-day inventory. We offer fast turnaround on quotes for catalog as well as custom designs, and first article inspection for customers who require this service. Test data is available.